Hello, hello, welcome to version number 1 of the second unit's practice exam. So looking at our classic number 1 true-false questions, we have if each term in a polynomial expression shares a common factor, we can divide the polynomial by that common factor to create an equivalent polynomial expression. I know that was pretty long, but let's just understand what the question is saying. So given a polynomial expression, and they're saying that if each term shares a common factor, then that means we can extract that common factor out by division. So for example, let's say we have something like 3x plus 6. So if we're only talking about expression, this is saying that if we were to divide by the greatest common factor, in this case 3, it's claiming that it will create an equivalent expression. But that's not true. 3x plus 6 is not the same thing as x plus 2. Because if we were to substitute in numbers for x, then the two resulting expressions are not going to be the same. And so the only time that we're allowed to use division or divide a polynomial by some sort of common factor is if we're solving an equation, not an expression. Okay, so let's look at number 2. We have the expression x plus 5 squared is equivalent to x squared plus 25. So this is, again, a very common gotcha, well, not even a gotcha question, because it's just a very common mistake that students make, which is they think, oh, I see a power of 2, and that tells us that we can distribute the power, which is absolutely false, because distributive property does not work with exponents. Distributive property only works when it's over addition or subtraction. So in this case, x plus 5 squared technically represents x plus 5 times x plus 5, which then simplifies to a trinomial, x squared plus 10x plus 25. So again, very common mistake, don't get got on that. Let's look at number 3. Here we have the graph of the equation 64 times x plus 10 equals y minus 6 squared will be a parabola which opens to the right. So let's just first identify, well, looking at this equation as such, we want to think to ourselves, well, is this going to be a up-down parabola, or is it going to be a left-right parabola as such? And so because of the existence of this y squared, we know for sure that it cannot be an up-down parabola that we're used to seeing, because that's generally in the format of y equals x squared or any transformations from that. So the existence of a y squared verifies that it indeed is either pointing to the left or pointing to the right. And then so based on that, we have to identify the value of p, because that then tells us the direction that the parabola points in. So we see this constant right here, and so this is always going to be equivalent to 4p. So if 64 is equal to 4p, regardless of if you know the answer or not, p must be positive. So if p is positive, that tells us that the vertex to the focus is going in a positive direction, forcing our parabola to point to the right. So therefore, number 3 is correct. Okay, let's look at number 4. We see in the equation y equals ax squared plus bx plus c, if a is less than or equal to 0, then the parabola will have a maximum. So let's just break down what this part is saying. So a, we see, is the leading coefficient of the equation, and we know that the value of a will affect the direction in which the parabola will open towards. So if we break it down, well, notice very carefully, this says a is less than or equal to 0. So we know for sure that if a is less than 0, then the parabola will have a maximum, because that tells us that the parabola is pointing downwards as such, forcing the vertex to be a maximum. But notice here that, again, this is a compound, well, no, not a compound inequality, but it's less than or equal to. So if it's equal to a, well, what direction would the parabola open in? If we remember from a while ago, we kept saying a cannot equal to 0, because otherwise the equation is no longer a quadratic equation. It's no longer a parabola. Because once again, if we were to substitute a equals 0 into the equation, then we would have 0 times x squared, which completely eliminates that, leaving us with bx plus c, and that it's linear. So 3 is the only true statement here. Let's look at number 2. Number 2 says, if the polynomial function f follows this form of x squared plus bx plus c and has two roots at -1, 0 and 2, 0, which of the following is an equivalent form of the polynomial in which the coordinates of the vertex appears as a constant in the equation? Okay, that was a lot. So let's just identify the objective truths that we know. So we know for sure that this is our general equation. Notice here specifically that there is no value of a other than 1. So here we can assume that a is equal to 1, and we know our two roots. So we know our roots are -1 and 2, and we know that in this case a is equal to 1. Another thing that we want to notice is that looking at all the answer choices, they're all in vertex form. So if they're all in vertex form, even if there was too many words in the problem, we can just see that, well, we need to find the vertex using the information given to us. So if we remember, every single time we talk about the relationship between the roots and the vertex, we know the vertex. In order to find the vertex, we need the axis of symmetry. And the axis of symmetry is always midway between the roots. So for example, if we were to graph it, randomly graph it like this, something like that, our roots of -1 and +2, the vertex or the axis of symmetry will always be midway between the roots. So in turn, we want to find the middle number between the roots, or in other words, we take the sum of the roots and divide by 2. And so the sum would be -1 plus 2, all divided by 2, and that gives us 1/2 as such. And so that tells us from here that our axis of symmetry, or the vertex, will have an x value that is half. And so looking at our answer choices, we can already eliminate C and D because they don't have an x value, or the vertex does not have an x value of half. So therefore, we're left with A and B. Now the question becomes, well, how do we verify which of these is the correct y value? So from here, we got to substitute into our general equation or expression that we had from before. And so once again, because we know A is equal to 1, we can rewrite this as such. So from here, we can write this into factored form, mainly y equals A times x minus p and x minus q, where p and q are the roots. So knowing the roots, substituting what we know again a is 1, and with the roots our factor should be x minus 1, x plus 1, and x minus 2. Because once again, if we employ the zero property, that will allow us to find the roots as such. And then so from here, now, because we know the axis of symmetry is x equals half, we're going to substitute half into the equation just so that way we can calculate what the y value of the vertex is. So again, half is the same thing as 0.5. So substituting that into our equation, then that gives us y equals 1.5 times -1.5, or in other words, y is -2.5, which translates to -9/4. So let's say hypothetically you see this on the test, -2.25, and you're having a huge brain fart and you don't know how to convert it into a fraction real quick. This is something that I don't like talking about, but I will say it just in case if you have a big brain fart. To convert from a decimal into a fraction on your graphing calculator, you just have to press the button math, and then it will lead you to a like another screen, and you want to press the first option which says frac, and that changes your number or your decimal into a fraction. And so with that, once we know the axis of symmetry and the y value of the vertex, that gives us our final answer, which is choice A. Yay. Okay, let's look at number 3. So number 3, you can approach this in many different ways. So it says circle each expression that is equivalent to 4x squared minus 4x minus 120. So if we look at all the answer choices, yeah, you could spend your time multiplying out everything and seeing if it is equivalent to the original, but it's not necessarily time efficient. So what we can do instead is factor. But if you want to multiply, I can't stop you. So let's look at the first answer choice. So if we look carefully, that's telling us that, well, here we have a 2 that's factored out. So let's try that ourselves. So if we were to factor out a 2 from each term, and once again, because it's an expression, we cannot divide out the factor of 2. We have to keep it. So we have 2 times 2x squared minus 2x minus 60. So that indeed, if we were to distribute and just double check, yep, indeed, that is correct. And if we look, so right here, we can verify choice 1 is nice. Now, choice 2 looks a little bit ugly, so maybe let's move on to choice 3 because it's the same exact idea, but now they're factoring out a 4 instead. But, oh, whoops, factoring out a 4. So let's see. So we have 4 times x, 4 times x squared minus x minus 30, and that indeed is also correct. Yay. Okay, so we secured that. So what we can do from here is to break it down even further, because now we see a trinomial that we can factor. Because we see that the trinomial has a leading coefficient of 1, then we can think to ourselves what two numbers multiply to negative 30 and add up to negative 1. And so in that case, that will give us the 4 stays as it is, and then this will give us x plus 5 times x minus 6. Because once again, positive 5 times negative 6 is negative 30. And if we were to add them up, positive 5 and negative 6 gives us negative 1, exactly what we want. So if we look at what we have here, comparing it to answer choice number 4, well, notice very carefully, the signs are not correct. The signs are not correct. So therefore, number 4, bad. Now, you might be thinking, well, what about number 2? We didn't check number 2, and that's where this is going to come into play. Because if we notice carefully, here they have a factor of 2. And then one of these factors is divisible by 2. So what that tells us is that we can do as such. We can break down the 4 into 2 times 2, and then keep the x plus 5 and the x minus 6 as such. And so in this case, to create that 2x plus 10, they multiplied the 2 and the x plus 5 as such. And so doing so, we can double check. The 2 stays as it is, and distributing the 2 to one of the factors, we have 2x plus 10 times x minus 6. And, well, we see number 2 is also correct. Yay. Okay. And then, so let's look at the last one, number 5. So number 5, oh, whoops. Okay. Number 5 is right here. We got 4x times x minus 1 minus 120. In this case, you can't avoid distribution, so just distributing the 4x to each. Let's see if it's the same as the original. We have 4x squared minus 4x minus 120, and yep, this is also the same, so this is also true. So we have 4 answers for number 3. Let's look at number 4. Number 4 says, a parabola whose vertex is at the origin and whose focus is 0, 10 has the equation blank. So once again, we can approach this in many different ways. So one way is to draw out what we know. So again, the vertex is at the origin, or in other words, 0, 0, and the focus is at 0, 10. So if we were to draw it out, vertex is at the origin, and the focus is going to be forced to be above as such, 0, 10. And so from here, we can extract the value of p. So we know that p is the directed distance from the vertex to the focus as such. And so we see since the y values are changing, we can see from 0 to 10, we just add 10. So that tells us p is equal to positive 10. And we also know p is positive in this case is because if we were to draw the parabola, it must go through the vertex such that the focus is kind of like cupped or inside the parabola as such. And so with that in mind, we know that we're going to have a parabola that either points up or down, but in this case, we already know it points up. So this is our general equation. We have y equals 1 over 4p times x squared. And so we're using this format because the vertex is at the origin, 0, 0, so it's not necessary to write the vertex form of this equation. So once we substitute in what we know, we have y equals 4 times 10 in the denominator times x squared as such, giving us our final answer, 1 over 40 x squared, which is answer choice 2. And so let's say you didn't want to write this out. Another thing that we could have done to find the value of p is to take the focus, which is this coordinate right here, and again, because the y values are changing, we're going to fixate on the y value, so starting from 10, and we have 10 minus 0, and that gives us our p value of 10, positive 10. So either one is perfectly acceptable. Let's look at number 5. Number 5, here they tell us, given a function f of x equals negative 2x squared plus 28x plus 30, they're asking us to rewrite f of x in vertex form by completing the square. So again, we got two different methods. I'm going to go over the shorter one first and then the longer one, but either one is perfectly fine. So method number one is what you would typically see on delta math. So just recopying the equation, we have f of x equals negative 2x squared plus 28x plus 30. So we know for sure that every single time we're trying to complete the square, we need to satisfy two criteria. A must equal to 1, and we want to isolate all the values of x as such. So doing it the delta math way, we want to factor out the negative 2, but only from the first two terms because we're trying to complete the square. So we want to isolate the values of x and make a equal 1. So we have negative 2 times x squared minus 14x, and then leave a blank plus 30. So once again, all we're doing so far is just extracting a factor of 2 from the first two terms, and as of now, we have not changed the value of the equation. These two equations are equivalent. So now when we decide to complete the square, or in other words, forcing the creation of a perfect square here, then we have to maintain balance in our equation. So let's just first identify what do we need to put here in order to complete the square. So again, to complete the square, we need b over 2 squared. And in this case, b would be negative 14 because we're going to use this value of b to create a perfect square. So that gives us negative 14 over 2 squared, or in other words, negative 7 squared, which is positive 49. So we're going to add a positive 49 inside our equation as such. Did I write it? Oh, here. Plus 49. Now, at this point, we've changed the value of the equation from the original. So what we want to think to ourselves is, how do we undo this effect that we just did? So even though it looks like we just added 49, in reality, if we were to distribute this, distributing the first two terms will guarantee that we have these two terms as such. But once we distribute the negative 2 to the 49, then that tells us that we changed the equation by negative 2 times 49, which is negative negative 98. Yeah, negative 98. So we've changed this equation by subtracting 98 because that's the value of negative 2 times 49. So now we want to think to ourselves, how do we undo that? And to undo that, we're going to subtract whatever negative 2 times 49 is. Negative 2 times 49 as such. So I would just recommend to always just write minus and then whatever a is and whatever we completed the square with. Because what we did was we included a negative number from the first equation to the second. So to undo it, when we subtract a negative number, then it becomes addition. So that way it undoes the effect of what we just did as such. So now we have f of x equals negative 2, and now we can factor this entire perfect square trinomial into a perfect square, giving us x minus 7 squared plus 30, and then simplifying all of this gives us plus 98 as well. And now finally combining like terms of 30 and 98 gives us our final answer. F of x equals negative 2 times x minus 7 squared plus 128. And that's it. We're done. That's vertex form right there. So in my opinion, I would say this is a lot easier in terms of time. It will save you a lot of time. But this portion right here, the whole idea of undoing the effect of completing the square might be the gotcha portion of this method here. Now let's look at method number 2, which is this whole idea of very similarly following the steps of completing the square if we were to solve an equation, but it can get really annoying because there's a lot of back and forth. So once again, let's start off with the equation. And we know that in order to complete the square, we need a equal 1, and we need to isolate the values of x. So to do that, we can subtract 30 on both sides first, thus giving us f of x minus 30 equals negative 2x squared plus 28x. And then from here, we want to divide by negative 2 to secure a being 1, or the leading coefficient being 1. So this is what we have as of now. F of x minus 30 divided by negative 2 equals x squared minus 14x. So once again, this is exactly what we want. We want the leading coefficient to be 1, and we want all the x values on one side of the equation. So that way we can start completing the square. And very similar to the method above, to complete the square over here, we have negative 14 divided by 2 squared, giving us, in other words, 49. So we're going to add 49 on both sides of the equation. So once again, there's nothing wrong with adding 49 as such, but we just have to remember that we're adding it to this very large fraction. So we're going to have to convert 49 over 1 into a fraction that's equivalent with a denominator of negative 2. So then that therefore will give us negative 98 over negative 2, because negative 98 divided by negative 2 is positive 49. So even though it looks different, we're technically adding the same value on both sides of the equation to maintain equivalence. And then so from here we can factor the right side, and that will give us x minus 7 squared. And then on the left side, we can combine like terms since the denominators are now the same. So we have negative 98 and negative 30, and combining that gives us f of x minus 128 all over negative 2. So from here, we have to remember the whole point is to isolate f of x. We're just completing the square. So from here, we want to eliminate this denominator of negative 2, and we're going to do that by multiplying negative 2 on both sides of the equation as such. So once we have this down, this gives us f of x minus 128 equals negative 2 times x minus 7 squared. And again, our last move is to isolate f of x by adding 128 on both sides. And that gives us the same exact answer of f of x equals negative 2 times x minus 7 squared plus 128. And so from here, part B says to state the coordinates of the vertex. So this is already in vertex form. So we have x comma y, or h comma k for our vertex, and that would be 7 comma 128, and that is our final answer. So again, the reason why it's not negative 7 over here is because this minus 7 tells us that the graph is shifting 7 units to the right, which is a positive 7. Let's look at number 6. Number 6 says to write an equation of a parabola with a focus of negative 3 over 2 and a directrix of x equals 5. Be sure to show algebraic and or graphical work demonstrating how you arrived at your answer. So, I have no idea what I wrote in here. Okay. Oh, every single time they ask us to write an equation of a parabola, we always need two things. We always need to find the vertex, and we need to know p. P, again, is the directed distance, or in other words, the distance from the vertex to the focus, or from the directrix to the vertex. So again, we're saying directed distance because p could be either positive or negative, and it tells us which direction our parabola is going to open towards. So let's do the graphic one first. So on the test, you don't have to do it both ways, but this is either way of showing work is perfectly fine. So what we can do is just to graph or sketch out what we know so far. So we have a focus of negative 3, 2, and we have a directrix, which is x equals 5. So I like to start off with the directrix, but if you want to do the focus, it doesn't matter. So the directrix, x equals 5. The moment that we see x equals a number, we always know that that's going to be a vertical line because it has an x-intercept. So therefore, we have x is equal to 5. And then so from here, we want to think, if we were to graph the focus, where would it exist relative to the directrix? Would it exist on the right side or on the left side? And so because this is x equals 5, the focus is forced to exist on the right side as such. Because here we have the x value of negative 3. And then from here, now we got to extract information about the vertex and p. So again, the vertex is midway between the focus and the... I covered this terribly, lol. So we know the vertex is midway between... I covered this terribly. Oh well. Oh well. I'll live with it. Okay, so the vertex is midway between the focus and the directrix. And so from here we can see that overall what's changing is the x values. So from negative 3 to positive 5, there's a change of 8. And so if the vertex is halfway, then it's going to be 4 units from the focus to the vertex and 4 units from the vertex to the directrix. So doing that arithmetic gives us our, in this case, value of p, which is -4, because we're going in a negative direction as such. And that gives us our vertex, which is 1, 2. So if that doesn't make sense, let's double check. So from the directrix to the vertex, is it 4 units away? Yes, because 5 minus 4 is 1. Same idea here. From the vertex to the focus, we have 1 minus 4. That gives us -3. Yep, that is also correct. So that's how we can find P and the vertex using the drawing. And also from here, we can also tell that the graph is going to point to the left because, once again, we know that the parabola cannot intersect the directrix. That's illegal. And so therefore it intersects the vertex as such that the focus is in the middle or cupped by the parabola. So that's what we know. Or if we were to do this algebraically, then what we can do is, because of this principle that the fact that the vertex is midway between the focus and the directrix, then what we can do is find the midpoint, or in other words, find the average. Or we can approach it using P. So there's two different ways of approaching it. So the first way is, how did I do it here? Oh yeah. So the first way is what I said before, which is finding the average. So in this case, -3 plus 5 divided by 2 gives us 2 over 2, which is +1. And that is the x value of our vertex, because x equals 1 is in the middle of when x is -3 and x is -5. What did I put here? Oh, yes. Okay. And then so P tells us, again, the directed distance. And so we can find P by using what we know as such. So what we can do is we can use the -3, and we're going to subtract 5, and that's going to give us -8 divided by 2. So the reason why we're subtracting is because we're finding the total difference between these two x values. What was I saying? Oh yes. So that gives us P is -4. And so therefore, the vertex is going to be 1. Now, let's say if you're doing this algebraically, the question becomes, well, how do I know what the y value is? Do I have to substitute? No, because we always know that it exists on the axis of symmetry as such. So it's going to share the same exact y value as whatever the focus has, which is in this case 2. Okay, so either graphic or algebraic would be completely acceptable. And so from here, we're going to substitute to find our equation. So there's two equations that we can approach it as. We can do the one that we did in class, which is vertex form, or we can use conic form that we've seen briefly in class or on Delta Math. So either one's perfectly fine. All we just got to make sure is that we're substituting in our coordinates correctly. And once again, we're using these equations because we know our parabola is going to point to the left and right because of the graph, or just by looking at our coordinates, we see that the directrix is a vertical line, so it forces the parabola to be either pointing to the left or right. And so we have y squared, which does verify that the parabola either points to the left or to the right. So substituting in what we know, we have x equals 1 over 4 times -4. Now, a lot of people keep asking, do I have to memorize this part? No, we just once again have to associate the x and y values to their respective variables. So in this case, the vertex y value is 2, so that's what we know we're going to substitute into here. While the x value of the vertex is 1, and that's where we substitute on the outside. So therefore, this gives us our final answer of x equals -1 over 16 times y minus 2 squared plus 1. Or if you want to approach it using the other way, that's perfectly fine as well. That gives us the same, or yeah, an equivalent equation. Again, it looks different, but it's exactly the same. -16 times x minus 1 equals y minus 2 squared. So you don't have to do both on the test. Either one is perfectly fine, and it will give you full credit. Okay, let's look at number 7. Number 7 says, the equation of the parabola is given in 3 different forms below. Find the equation of the axis of symmetry and the vertex of the parabola 3 different ways. You must show all work clearly for full credit. So here we have Notice that they're all in the form of f of x. So that tells us, and even the problem says it too, it's the same exact equation. They're all equivalent equations, just written in different forms. So we have factored form, we have vertex form, and then we have standard form. So looking at here, we have factored form. So we just have to remember what is the relationship between the roots or the x-intercepts as well as the axis of symmetry. So based on what we have here, we can see that our roots are going to be -1 and +7, because by the zero property, if we were to set each of these equal to 0, that will give us our two solutions as such. And so we have to remember the axis of symmetry is midway between the roots. So all we have to do is find the sum of the roots, which is -1 plus 7, and divide it by 2 to find the middle value, which is our axis of symmetry, therefore giving us x is equal to 3. So this is what we know at this point. And so then from here, we're going to find the y value, or the output of the vertex. And so we're going to do that by substituting f of 3, or substituting x equals 3 everywhere we see x. So that gives us -½ times 3 plus 1 times 3 minus 7, or in other words, -½ times 4 times -4, and that gives us 8. So that tells us that our vertex is going to be 3, 8. And so you could totally graph this on your graphing calculator just to verify, but this is what it would look like image-wise. So we know for sure that it's going to be a parabola that points downwards because the value of a is negative, and our roots are -1 and +7 based on what we saw here, and our vertex is now 3, 8. So this is just a rough sketch of what the parabola looks like. Not drawn to scale and not accurate either. For the second part, here we have f of x equals -½ times x minus 3 squared plus 8, and we see that this is already in vertex form. So if we remember vertex form, that's f of x equals a times x minus h squared plus k, where the vertex is h comma k. So from here, our vertex is just going to be as simple as we think it is 3 and 8, so 3, 8. We should be expecting the same answer for each of these since they are equivalent equations. Let's look at the next one. F of x equals -½ x squared plus 3x plus 7 over 2. So in this sort of situation, once again, the whole point of this problem is to demonstrate how to find the axis of symmetry and the vertex in 3 different ways. So we've done it using the average of the roots, we've done it using the vertex form, and now let's do it by using our axis of symmetry formula, or otherwise known as x equals -b over 2a. So in this case, b is +3 and a is -½ So if we were to write that out, we have -3 divided by 2 times -½ or in other words, -3 times over -1, which is just +3. Exactly what we were expecting, because we already know the vertex from the first two parts. And then to find the output, we just substitute 3 back into our original equation as such, giving us h of, oh whoops, why did I write h of 3? It should be f of 3. F of 3 equals ½ times 3 squared plus 3 times 3 plus 7 over 2, or in other words, 8. So regardless of the method that we choose, all 3 of these will help us find the vertex and the axis of symmetry. So axis of symmetry, therefore we can conclude, is x equals 3, because once again, the axis of symmetry is the line that goes through the vertex and splits the parabola in half. So here they're going to have the same exact x value, x equals 3. Vertex, we've been finding that, that's 3, 8. Domain, now again, we're going to look at our makeshift graph right here. So our domain is all possible values of x. The question becomes, where does the graph span from left to right? And so we see that because the arrows continue down, not just completely straight down, but at an angle, it eventually will reach all the negative x values and all the positive y values as such. So we can say the domain is -infinity to +infinity, or all real numbers. And so from here now we look at range. Range becomes, well, what are all possible y values, or where does the graph span from down up, because everything's from least to greatest. So the lowest point, well, there isn't a lowest point because the arrows continue forever and ever. Therefore, that tells us that we're starting at negative infinity, going up to our maximum of positive 8. So that tells us our range is going to be parentheses negative infinity, comma 8 bracket. So it's negative infinity because there is no lowest point. And then we put a bracket around 8 because it's defined. It exists as a point. And then we can also say, or f of x is less than or equal to 8. Saying that all the values, all the y values, f of x, is starting from 8 and it's everything below it, which is less than 8. Now we have the next part, where is the function increasing? So we're looking at this graph from left to right. So when they say increasing, where's the graph increasing from left to right? So we see that it first increases, then it hits the vertex, and then it starts decreasing afterwards from there. So we're looking at this portion of the graph to describe where it's increasing. And remember, we're only talking about the domain because it's already implied that the y values are increasing. So we're just saying what part of the domain is the graph increasing. And we see it's increasing from negative infinity to positive 3. Because from the domain, there's no end to the x values, and then it stops at when x is equal to 3. And once again, we put parentheses around this because we're not, once we hit the vertex, we're neither increasing nor decreasing. It's like a midway zone. So that's why we do not put brackets. It is a defined point, but at that point, we are not increasing. So that's why it's a parentheses. Or we can say x is less than 3. And so for the next one where it says where the function is decreasing, it's the same exact logic. We see that the graph is going down from left to right here. So starting at 3, the graph continues to decrease as x approaches infinity. So that's why here we have positive 3 comma infinity, or we can say x is greater than 3. Alright, moving on to the next page. I don't know if this video is taking me long because I'm tired or because like I'm over explaining or talking slow. I don't know. So props to anyone that got to this point and is actually listening through this whole thing. Okay, let's look at number 8. Number 8. Oh yeah. A ball is projected up into the air from the surface of a platform to the ground below. The height of the ball above the ground in feet is modeled by the function f of t equals negative 16t squared plus 64t plus 80, where t is the time in seconds after the ball is projected. Algebraically determine the appropriate domain for this function. Okay, that's a lot. So, let's go. So, if they're asking us for an appropriate domain for the function, well, let's think about why that even is. So, based on the value of a in this equation, we can already tell that the parabola is going to be pointing downwards. But if we're talking about throwing something into the air, it doesn't make sense for something to continue on forever and ever downwards. Hence why we have to have some sort of limitations for the domain. So by definition, domain is all possible x values. So if we're talking about all possible x values, in this case we're talking about t, and t represents time. So we're only interested in all possible times. So the time could start at 0, and then it must end when it hits the ground. So from here, that's why we want to find the roots. And we're going to set this equation equal to 0 because we want to find at what time does the ball stop moving, and that's when it hits the ground. So from here, that's why we set it equal to 0 once again. And let's do that, and let's solve for t by dividing both sides by negative 16 just to make the equation easier for us. And that thus gives us 0 equals t squared minus 4t minus 5. And then so from here, we can either use, well, there's a multitude of things that we can use. We can factor, we can complete the square, we can use the quadratic formula, but because this equation has very small numbers, this tells us maybe factoring would be easiest. So we want to think to ourselves what two numbers multiply to negative 5 and add up to negative 4. So in this case, we have t plus 1 times t minus 5. Because positive 1 times negative 5 is negative 5, and then adding them together gives us negative 4, exactly what we want. And then so from here, what do we see? We see two values that are being multiplied, and it gives us a product of 0. So that tells us we can use the zero product property, or in other words, t plus 1 is 0 or t minus 5 is 0, thus giving us our two answers of -1 and +5. So if we were to draw this out, this is essentially what is happening. The roots are at -1 and +5, but it doesn't make sense for time to be -1, hence why we reject that. So when the ball starts being released, that's at 0 seconds, or this height right here. And so when we're talking about an appropriate domain, we're saying the time from 0 all the way to when it hits the ground. And so that's going to give us our domain of from 0 less than or equal to t less than or equal to 5, or we can say bracket 0, 5 bracket as such. Because we're saying the domain represents all possible times. So it's possible for the ball to start at time 0 all the way to the 5th second. Look at Suga number 9. Algebraically solve the equation. Algebraically solve for. I just realized this sentence does not make sense at all. Algebraically solve for equation 4 below 4. Okay, whatever. So what do we see? What we see objectively is true is we see that there are 3 factors that multiply to 0. So that tells us that by the zero product property, each of these have the potential to be 0. So that way we can say -3x squared is equal to 0, 49x squared minus 64 is equal to 0, or x squared minus 5 is equal to 0. And I just realized this is not straight. Okay, now it's okay. So solving the first one for x, yeah, you could totally divide by -3 and everything, but that's just a lot of work. This is just going to be x is 0. That's the only answer that's going to make this entire expression equal to 0. And then in the middle, we can add 64 on both sides, then divide by 49, and then we have x squared is equal to 64 over 49. And so from here to solve for x, we take the square root of both sides of the equation, thus giving us x equals plus minus 9 over 7. And then for the last one, we can add 5 on both sides, giving us x squared equals 5. And once again, to eliminate the power of 2, we take the square root of both sides of the equation, thus giving us x equals plus minus square root of 5. And then that gives us our final solution set. We have 0, positive 8 over 7, negative 8 over 7, positive radical 5, and negative radical 5. So let's look at number 10. Number 10, here we have algebraically solve. I just realized this is wrong too. Oh, good. Oh, gosh. All right. So whenever we see any sort of equation, what we know for sure is that we want to set it equal to 0 so that way we can eventually, hopefully, use the zero product property. Or maybe even completing the square or quadratic formula if you're really pleased. But let's first make the entire equation one side equal to 0 by adding 10x and subtracting 6x to the third power on both sides of the equation. So once we do that, that gives us a result of -2x to the third power minus 22x squared minus 48x equals 0. And so from here, because the equation is equal to 0, and we're not writing it into vertex form or anything, we're only solving for x, that tells us, well, we can simplify the equation now by dividing both sides of the equation by -2. And so that thus gives us x to the third power plus 11x squared plus 24x is equal to 0. So you might be wondering, well, why can't we divide by -2x, because they all technically have a factor of x? So the reason why we cannot divide by -2x is because there's a possibility where x is 0, and we cannot divide any number by 0. So that's why we leave the variables as it is. So from here, now let's look. What we want to think to ourselves first is there a greatest common factor? And in this case, there is. There's a value of x that they all share. So factoring out the x, we have x times x squared plus 11x plus 24 equals 0. And now we see a trinomial such that the leading coefficient is 1, and it's a quadratic. So now we can ask ourselves that question that we usually do. What two numbers multiply to 24 and add up to 11? And so that gives us x times x plus 8 times x plus 3 equals 0. 8 times 3 is 24. 8 plus 3 is 11. Exactly what we want. And then now we can use the zero product property and set each factor equal to 0, thus giving us our three solutions. X is 0, x is -8, and x is -3. And that's it. Now let's look at number 11. Number 11 says to solve the equation below by completing the square. So here we're forced to use completion of square, but again, every single time it says to solve for x, find the roots, determine the x-intercepts, find the solutions, whatever it is, we can use whatever method we want. We can use factoring, completing the square, or quadratic formula. But in this case, we're forced to complete the square. So writing the equation as it is, once again, what is the two criteria that we need to complete the square? We need a equals 1, and we need to isolate the values of x. So let's do that by dividing both sides of the equation by -2, and that gives us x squared plus 12x minus 284 equals 0. And then from here, let's isolate x's by adding 284 on both sides, thus giving us what we have as such. So we're leaving a blank there because we know that we're going to complete the square. We're forcing the creation of a perfect square here. So in order to do that, we're going to add b over 2 squared on both sides, which is, in this case, 12 over 2 squared, 6 squared, or in other words, 36. So we're going to add 36 to both sides of the equation to maintain equivalence to the original. And now let's simplify the left side and factor that as x. Oh, whoops, I done goofed. It should be x plus 6. Oh, jeez. X plus 6 squared is equal to 248 plus 36, which gives us 320. And then now let's take the square root of both sides of the equation in order to isolate x, because the whole point of this is to solve for x. And so I'm going to simplify radical 320 on the side as such. So this is a larger number than what we're used to, but because we see that it ends in 0, why not try dividing by 5? So if we were to divide by 5 or 10, whatever it is, dividing by 5 I would say is best, because then that gives us radical 64 divided times radical 5, or in other words 8 radical 5. So here that gives us x, in this case x plus 6 equals plus minus 8 radical 5, and then we're going to subtract 6 on both sides, which I done goofed about before, so let me just fix that for y'all right now. Yes. And so that gives us our two solutions. We have x equals, let me erase this because I goofed. Whoopsies, sorry y'all. Okay, so that gives us our two solutions. We have -6 minus 8 radical 5, or -6 plus 8 radical 5. And so from here, the question didn't say to write it in decimal form. Okay, so that means that we're done. But let's say hypothetically, because I believe I put it on the other practice exam, which is if they ask us to round, when we substitute to the nearest hundredth, we have 23.89. And then for the other one, we're going to have 11.89. So that's how we would write our answers if they ask us for a decimal version. Okay, let's look at number 12. And so number 12, they give us this equation, and they're asking us to find where the parabola opens. And all these other parts. Okay, so there's two ways of approaching this. So we can approach it by looking at it in the format that it's already in, which is this one right here in conic form. 4p times y minus k equals x minus h squared, and I'm just recopying it below. Or we can approach it by rewriting the equation. So let's do the method 1 first. So if we were to align up everything that we know, we can see that 4p is the same thing as -32, and that's going to allow us to find the value of p. In this case, p is equal to -8. And then this also tells us the vertex as well, which is h comma k. H comma k. In this case, it's going to be 2 comma 3, and that's our vertex. So our vertex is 2 comma 3. And then so I put a set of axes on the side in case you wanted to use that to find the parts of the parabola. And so from here, we know that the vertex is in the middle. We have 2, 3. If P is -8, then P is either going to go down or to the left. But because this equation has an x squared, then that tells us it's an up or down parabola. And so from there, we know that's going to point down. So P equals -8 goes down by 8 units, forcing our focus to now become 2, -5. Because the y values are changing since we're going down. So we have 3 minus 8 gives us -5. And so that gives us our focus, 2, -5. And once again, because these 2 points exist on the axis of symmetry, they both share the x value of 2, so that gives us our axis of symmetry, x equals 2. And so the directrix is now going to be above the vertex, so now going the opposite direction, or in other words, increasing by 8, forces our equation to be y equals 11, because 3 plus 8 gives us 11. So that's our directrix. And again, the parabola opens down because P is less than 0, so as such, and there exists an x squared. So there's an x squared, so that's how we know it's up or down. Okay, so that's one way of approaching it, or we can look at method number 2, which is to rewrite this into vertex form if that's okay, if that's something you're more familiar with. So what we can do is multiply both sides of the equation by 1 over -32. I'm too lazy to write it here, but I already committed. Okay. That gives us y minus 3 equals 1 over -32 times x minus 2 squared. And then from there, we're going to add 3 on both sides to give us our vertex form right here. Regardless, we get the same exact information. We see the vertex is 2, 3. And we see that here, this is 1 over 4p, also telling us the value of p. So either method is perfectly fine. This concludes the video, and I'll see you on the next one. Bye.